tools and to use the tools that make the platform sing. But actually, before I do that, I'd like to see it by the light here so I can get a sense. It's probably even fewer. How about software development, Java, JavaScript? And there does seem to be extremely rapid growth, what Mark Andreessen likes to call hypergrowth in web usage. I've seen numbers like 20 million. We saw this morning numbers like 25 million. I've heard numbers as high as 40 million worldwide. Pretty scary, pretty impressive, pretty amazing. There's been rapid growth, albeit not quite as rapid, in the amount of web content. Pretty fast, pretty darn fast growth in the number of web servers. And gee, while all this has been happening, probably reinforcing all this happening, is there's been a great increase in the richness and diversity of the kind of web content that is possible, that we consider as a possibility for our design, for our development. For example, you sort of see this in the fact that I have estimates from anything from September to March here, and guess that would double in the following.
It can actually use an arbitrary protocol to talk to an application server running on the web server. We call that protocol TBDP, or to be determined protocol. But what that will allow you to do is potentially dynamically load balance an application between client and server and share Java-based business rules or potentially application logic written in C or Object Pascal or BASIC or any number of other languages running on the server, as well as share a set of stored procedures for going against heterogeneous backends. So that's really the distributed computing platform that we see evolving because of Java and because of the Netscape platform. Borland's going to be providing pieces to serve this end-to-end platform. Latte, which is the ability will give you the ability to build Java applets and applications. Nexus, which is an application server, which will provide a runtime repository for storing Java applications and managing communication and accessing SQL databases. And then finally, we actually have our own relational database called Interbase, where we're adding not only JDBC support, but support for user-defined functions written in Java, which is going to mean you're going to be able to program the client, the application server, or the relational database end-to-end in Java, making it very convenient from a productivity perspective. So let me talk to you about the architecture of a just-in-time compiler plugged into a browser such as Netscape Navigator. The Java byte stream comes down the wire. Now, a Java byte stream is really just data that gets interpreted. So first, the virtual machine, or the VM, does the security check on that byte stream. So just-in-time compilation does not do anything that would impede the security capabilities. Make sure that the Java byte stream has integrity, it is as the author intended it to be. The virtual machine checks to see if there is a just-in-time compiler present, which is just another DLL. If it's present, when the first method of the Java applet is called, instead of calling it, it calls the just-in-time compiler. Our just-in-time compiler actually then, on the fly, generates native code for the method that's about to be executed, and then patches the V table so that each subsequent call to new methods will actually first come through the just-in-time compiler. So with each method call, the just-in-time compiler compiles it to native code, thereby expanding the amount of native code you have, and then patching the V table to come back, and then through each subsequent pass through the code, it's running natively. This process actually happens faster than the interpretation process can. In fact, if you take a look at some of the features of our app accelerator, which is the name of our just-in-time compiler, it compiles at 1.2 million lines per minute on a Pentium 90. That's fast. Delphi compiles at 350,000 lines per minute on a Pentium 90. So you get the idea that if you've used Delphi or seen it compile, this is fast. Now, we can't find 1.2 million lines of Java code, so you better get to work. But as an example, we compile the bytecode compiler that's included in the JDK pretty much so instantaneously. If that's not good enough for you, the compilation is incremental, as I described, and it's generating right now native x86 code. The DLL that makes up the just-in-time compiler is just 90K. So if you look at the benefits you get from this, your Java code runs 5 to 15 times faster than interpreted. So you're getting an environment where we're getting the kinds of performance benefits that we got with Delphi over a Visual Basic or a Power BI. You're getting instantaneous compilation that is transparent to the end user. They just are seeing the native code execute. And you've got a very small footprint, so very low overhead. So what I'd like to do is, if I can switch to this monitor here. Working on it. There we go. What we're looking at here is our Java integrated, our just-in-time, the JDK integrated into Borland C++ 5.0, which will be available in storage.
Yeah, I know.
Best seats in the house.
And also the people at Apple.